here as we look to integrate this rational function, we see the denominator is already factored, won't factor anymore, so we're going to do partial fractions, get that split up. So we have x squared plus 3 over x plus 1 times x squared plus 1. And so for our partial fractions, we need one denominator that's x plus 1, and the other one needs to be x squared plus 1. So the numerator here is a, but because this is quadratic and won't factor anymore, the numerator here needs to have an x term, so bx plus c. Now if we cleared this of fractions, this is gone, the x plus 1 would cancel and leave an x squared plus 1. Here make sure you get parentheses, both of these terms need to be multiplied by the x plus 1 that's left here. Now because we had this quadratic and we've got this to FOIL and this x term and this so forth, convenient x isn't going to be quite so convenient, so we're going to equate coefficients. So we're going to multiply everything out. So we're going to distribute this a through ax squared plus a. This will need to be FOILed, plus bx squared plus bx plus cx plus c. Now we're going to look at each type of term, and the only way that a polynomial on the left-hand side can equal the right-hand side is if the coefficients are equal. So first of all, we're going to look at the x squared terms. On the left-hand side, there's a coefficient of 1. On the right-hand side, there's coefficients of a plus b. So that's our first condition that must be met. Now we're going to look at the x terms. On the left-hand side, there are none. On the right-hand side, we have a b plus a c. And now we're going to look at the constants. And what we mean by constants is, in this particular case, is no x. So we have 3 equal a plus c, right here, a plus c. Now this is a system of equations. They all need to be true. You can solve those with matrices or whatever, but these are actually pretty simple ones. So I think what I'm going to do instead is find that b equals negative c from this equation right here. And so we could substitute in for b right here, and we would have 1 equals a minus c, and we could combine that with the 3 equals a plus c equation. The c's would go 2a equals 4, so a equals 2. Well then, if a equals 2, we could substitute that in to find b. So 1 equals 2 plus b, so b must be negative 1. And then here's our connection between b and c, so if b is negative 1, c must be 1. So this was easy to just do some quick substitutions because we had a lot of terms missing. Alright, then this integral can be split up into, a was 2, so 2 over x plus 1 plus b was negative 1, so negative x, c was 1, plus 1 over x squared plus 1 dx. So now that we have this split up, we are ready to see what we can do to integrate. So I'm going to go ahead and get rid of our work for our partial fractions, so we've got room to do the integration. What I'm going to want to do is I can easily deal with this first one. I'm just going to write down what it is. It's going to be the integral of 2 over x plus 1 dx. Now here, because we have two terms in the numerator, we can actually split this up and apply the denominator to both pieces. So let's do that. So this one would be minus integral of x over x squared plus 1 dx. And then we're going to have plus integral of 1 over x squared plus 1 dx. Now we have this down to 3 different integrals. Let's see what we can do about integrating. This one we can see would be 2 times the natural log of the absolute value of x plus 1 minus, here we could do a u substitution and let u equal x squared plus 1, and then du would be 2x dx. And we don't have the 2, so if we compensated for that with a 1/2, this is going to end up being 1/2 out in front from this, and then the natural log of the absolute value of x squared plus 1. And then plus, as I look at this, I recognize that as an inverse tangent of x, and then plus a constant. If you weren't sure about this, didn't recognize that, you could draw a triangle and do trig substitution.